Hello my friend, today we are going to talk about a very important topic and it's vector. What is vector? Vector is just a container that has got in the behind scenes, so somebody has programmed it, something very similar to array, which means that this is a container that can hold values one after another. You can access them using indexes like normally you would do. But the syntax here is a bit different to create a vector, right? You can access the front of vector to access the first element. You can access the back, so the end of the vector, using the back method. And well, you can hold values inside. So why do we even bother learning about vectors when they are so similar? They have two methods like that. Maybe are there more of them? Yes, there are many methods. We'll talk about them in future. But there is one very important difference between the vector and array. Whenever you add a new element to vector, it's gonna be automatically increased. Okay, so when you add fourth element, well, fifth in this case, because 1, 2, 3, 4, fifth element, it's gonna be added here without any problems. This vector is gonna become bigger when you add a new element to it. Okay, you can insert elements here in between these two elements, a new one. You do not need to change the values, like for example change the value of the third element, the fourth element, in order to insert something here, right? You can just put something here between this and this. So this is pretty powerful, right? This gives us a bit more options than the array, right? You don't need to know the size of vector when you are creating it. You can just create a vector, that's all. You create a vector and you can just use it. You don't need to ask the user who is gonna use your program things like how many users are you gonna add, right? And then, okay, he wants to add 5 users, so let's create an array with the pointers with the dynamically allocation for 5 users. Or maybe let's for example create a 10 element array just in case, right? This is not the way it should look like, right? Everything here works in the behind scene. You do not need to at all think about that. That's cool, okay? That's why I love vectors. So how to use vectors? In order to do it, we need to include vector at the top of your program because this is the external library. So include vector, then you need to type the vector because this is the object, and to be honest, vector is a template class. So in order to create a template object, right, you need to specify what types are gonna be held inside vector, what types of variables, right? And in our case, we say it's gonna be integers. You could type here, string, you could type here your own type, right? It's just informing what types are gonna be held inside vector. In our case, we're gonna put their integers. That's why we call this vector whole numbers, because integers are whole numbers. And now we can do many things with that. We can, as you can see, do many things. But first, let's focus on the method that is called push back. What does it do? As the name suggests, it pushes to the back the value that we're gonna send. In our case, like here, we have an empty vector. It's gonna put it here, right, at first position. If we had 4 elements like here, it would add it at the end, at the back of the vector. So let's do something like that. Push back 1. What other elements we need? 24 minus 45. And 350. So we have just pushed back 4 times. So we put something at the end of the vector, new values, right? We need to remember we can't put here values that are not integer now, right? Like that. As you can see, we have got an error here, okay? Because this is string. All right. So we've just pushed it back. So can we access this element somehow? Yes, we can. Because in the background, we have got really an array. Well, yes, we can do something like that. We can access elements like this. 0, 1, 2, 3. 125 minus 45, 350. Great. So we can access each element like this, or we can use the method like this. Method add. So get the element at position 0. Oh, okay, this element is 1. The cool thing is, as you can see, we haven't specified anywhere the size of vector, right? Normally, if we had array here, we would need to specify the size. Here, we do not need to do it at all. We can just add new elements. As many as we want. Can we change the values? Like, for example, can we change the value of the whole numbers, like, for example, this from the second position to, like, for example, 500? Is it possible? Yes, it is. So whole numbers like that. As you can see, that's how you change the value of the element at the position 1, 2, 3. So position on the third position to 500. You might be wondering now, why did I even learn about arrays? Arek, really, I lost so much time. Well, firstly, the vector is something that was invented later. That's the first thing. The second thing is that when you are increasing the size, like that, when you don't know exactly how many elements are gonna be in your program, then this is not like it's not like it's free, right? The things that happens here in the background. There needs to be things done in the background, right? So how can I show you this? Look, when I do something like that, cout whole numbers size, and size, we'll see that the size of it is 4 because we have 4 elements, right? Okay, that's cool. But there is something also like capacity. So it means how many elements this vector really can hold. So this is, as you can see now, 4. So it's impossible to add a new element now? No. It's possible, but when we push back another element, like, look what happens. We have got here size 5. So we have 5 elements. It's true, right? 1, 2, 3, 4, and 5. But capacity is equal to 8. So the amount of elements that can be held in vector is now 8. What happened here? Well, vector tries to assume how many elements are gonna be held in your vector in order to not, create a vector just in case that can hold, for example, 1,000 or 2 million of elements, right? Because that's not what you're gonna need every time. You need to remember that every integer is about 4 bytes, right? So it would be stupid to do something like that just in case. So when we had only 4 elements, the size was 4. But after we added the 5th element, it increased the size, the capacity of the vector to 8, because right now, if you add another element, it will not need to increase the size, the capacity, as you can see. Why does it do it like that? Well, imagine that normally, if you had to do it manually, right? If there were no vectors, if you had an array that is like 4 elements, right? Like 4-element array. And if somebody wanted to have, more elements, like 5 or 10 later in your program, you would need to copy entire array. You would need to get every value from this array and put it into another array that would be size of 10, for example. And you will need to delete this array, right? And well, it takes time, right? So that's why vector increases its capacity just in case a bit more, right? We have got now it at the size 8, just in case. When we start pushing new values like that, you will notice that when we get to the capacity, the size is the same, but when we again add a new element, the capacity increased to 16, so it doubled. Because the vector noticed that, well, okay, it's better to maybe create a bigger vector, okay? Because, well, it takes time to resize things in the background. So this is cool to have a feature like that, but this is not like free thing for efficiency of your program, right? So that's why when you know exactly how many elements are gonna be in your program, it's better to use arrays, for example. Otherwise, well, it's better to use it because it takes the job that you would need to do manually from you, right? It increases when it should increase. When you push too many elements to the back, right? You also don't need to specify the size of the vector at the start, right? That's why this is powerful. And of course, most time, this is the thing that you're gonna use, right? The next reason is why we haven't learned about vectors at the start is that this syntax is complicated. How would even somebody could explain to the person who doesn't know C++, what is this vector with this something like this angle brackets and int? What does happen here? Well, we have learned about something with this class templates already, right? But they were pretty hard comparing to what we have learned so far. So in order to understand what's going on here, you need to first learn lots of syntax from the C++, lots of content, right? It's not so easy to use like that. Well, you could just, tell, hey, you know what, that's how it works is all. You just type here vector and then you type int and this is just some kind of container and, well, that's all, right? But that's not how you should learn things, right? That's why first you learn about arrays. And the next reason is that, well, it doesn't mean that others are not using arrays anymore. If you see an array and it's gonna be used with pointers, especially in old libraries, you would be confused, right? If you knew only about something what is called vector. It's not like this would be stupid. And the next reason is that when we start creating now, when we want to start make things like, for example, inserting, notice that there is an insert method that allows you to, for example, insert something in the middle. You can't do something like, hey, let's insert it at the position 3 and let's put there, for example, 500. It's not gonna work. Why? Because here, in this place, we need something what is called iterator. Also, if you want to remove a value using the erase method, which is used for erasing values, also you cannot just put here 5. When we run this, as you can see, it's not working fine. You need to put the iterator. And this is also a bit complicated topic. And we're gonna talk about it in future lectures. That's only a lesson. Thank you very much.